Okay, so let's take a look at section 2.1, which is about slope fields. So definition, if you can write y prime as a function of x and y, it's called a slope function. Okay, recall that y prime gives you the slope of the tangent line at the point x, y. So let's look at some examples of slope functions. Okay, so here's an example, y prime equal to 2y minus 2 over x. This would be a slope function. The 2y minus 2 over x would be my fx function. This would be my fx function. So pretty much you'd have to be able to write the derivative in terms of x and y like we've done here to be a slope function. Let's look at an example of something that would be difficult to write as a slope function. So this example, we got y prime to the fifth plus 5x squared y prime squared plus 9xy, y prime minus 16x minus equals 9, sorry. So let you check, but it'll be very difficult to solve for y prime as a function of x and y like we've done over here. So therefore we can say we cannot solve for y prime very easily in this example. Okay, so next thing. Okay, so if y prime is a slope function, then we call the slope at xy the lineal element. Moreover, the collection of all lineal elements is called the slope field or directional field. So I'm going to show now, if we know the slope field, we can approximate the solution curve passing through a given point. So let me write that here. Okay, so written here. So note, if we know the slope field, we can approximate a solution curve passing through a given point. You might say how, so let's look at an example on how we would do this. So let's look at an example now. I'm going to erase stuff here now and we'll look at an example. Okay, so here's our example. Show that the function y equals x squared plus 1 is the solution of the initial value problem. And our differential equation is y prime equal to 2y minus 2 over x with y1 equaling to 2. So let's first find y prime. So y prime would be 2x. Let me write that here. So y prime is 2x. Now I'm going to put, in place of y prime up here, I'm going to put 2x. And in place of y right here, I'm going to put x squared plus 1, and I want to show that the two sides equal. So let's make those substitutions. So making those substitutions, we get then, so again, putting the 2x in place of y prime, which I've done here, and putting the x squared plus 1 in place of y, which I've done here, then multiplying this out then, so distributing this in here, and simplifying, we get then 2x squared plus 2 minus 2, the 2's cancel. We're left with then 2x squared over x, which equals 2x. So shown 2x equals 2x, so check. And also, well, let's check at when x is 1, the y should be 2. So when you put 1 in place of x up here, you can check it's 2. So again, putting 1 in place of x here will be 1 squared plus 1, which is 2, so checks. So therefore shown that it satisfies this initial value problem. Okay, now let's graph the solution curve. It's going to be a parabola, but it's going to be shifted up 1 on the on the y-axis. Sorry. So let's graph it here. Okay, so I've graphed it here. So it goes to the point 1, 2, so 1, 2. And so parabola shifts up 1 on the y-axis, going like this. Now let's look at some the slope of the tangent lines at some point. So here it's going to be horizontal tangent line. At the point here it's going to be like that, say, and over here like that. Got one there. Now suppose, let me put in a few more tangent lines. slopes of tangent lines. Okay, so putting a few more in. So now that you think about it, if you knew the slope of the tangent lines like I've drawn in here at every point, then you should be able to sketch the curve if you didn't know the curve. So now let me take away the our solution curve in there and just leave the tangent lines, the slope of the tangent lines remaining. So let me do it. Okay, so now I've taken away the curve and just left the slope of the tangent lines. So you can see the imprint of the curve still here. So we could actually redraw the curve in here using the tangent lines. So in particular, these slope of these tangent lines would be the slope field of our solution curve x squared plus 1 with the initial condition y1 being 2. So you can see if you knew the slope field, you could then use it to sketch the graph of the solution curve. That's the idea here. So in particular, if you didn't know that this was the answer, you could look at the slope field, and then from the slope field you could draw in the solution curve with this initial condition, y1 being 2. Okay, let's keep going. So in general, y equals cx squared plus 1 is a solution of the initial value problem, y prime equal 2y minus 2 over x, with y1 being c plus 1. So you can check that like we did the one up here. I'll let you check that. So these are basically going to be parabolas. So let's graph a few of these. Let's graph it when c is minus 1, 3, and minus 2. Okay, so I've added two solution curves in here. One when c is minus 1, it's going to be opening down this way. And then when you put minus 1 in place of c, y1 will be 0. So it'll be passing through this point. So it's opening down. And then when c is 2, say, putting 2 in place of c up here, y1 to be 3. So y1 to be 3 here. So it'll be going like this. You can see you can choose any c value. So the larger you choose the c, the more steep the parabola will be going up here. And the negative ones will be going down in here. So let me draw in the some of the slope of the tangent lines for these two parabolas. So drawing a few slopes of tangent lines for these two parabolas. Now let's take away the parabolas and just leave the slopes of the tangent lines. So doing that we get then. Okay, so I've taken away the solution curves and just left with the slope of the tangent lines. So you can then you could find, if you just knew the slope field, you could find the solution curve with the initial condition. So for example, when y of 1 equals 2, that's going through here, so it'd be the one in there. And then when y of 1 equals 3, it'd be up here, so it'd be going along this one. And y1 equal to 0, be here, this one down here. So in general, you'd have infinite number of solutions because c can be infinite number of things here. So let me draw in a few more tangent lines. So drawing in a few more. So again, so if you know the slope field, you can then approximate the solution curve by looking at the slope field. So for example, if I didn't know that this was the general solution and I was just given this slope field here, I could then sketch the solution curves, and just looking at it looks like they're parabolas. So again, if I wanted the solution to have the condition y1 equals 2, well, y1 equals 2 is right here. So I'd have to go along in here. Okay, so this method is only useful when it's difficult to solve the differential equation. So if you have the slope field, you can then approximate the solution curves. That's the idea. Alright, so we're done with this section. Let's leave it there.